Welcome everyone. Today I will be showing an example of an integral that can be solved very nicely with the method of substitution, also called u-substitution. As you can see, it is an improper integral with its upper bound being infinity, and it is of a function of x that rapidly approaches zero as x grows larger and larger. So just by looking at this integral from the outside, it definitely does seem to converge. But how do we actually find the answer to this? Well, pause the video right now if you want to give it a try. Here's a hint: use the substitution method, which I will be covering before I reveal the solution right now. So the first step here is to notice something about the denominator. It looks very much like the square of a binomial, and it in fact is the square of a specific binomial, which will be x cubed plus 1. And you can verify this yourself, it is quite obvious. But now this is very nice, because we have both a square term in the numerator and in the denominator. And very often if you have an integral with a fraction where the numerator is of some power and the denominator is the same power, it is very wise to substitute some variable for the term in the denominator, because then there's a high chance that in your new integral of that variable, the old variable will cancel out. And that is precisely what will happen here. We're going to let some new variable, commonly we use u, to be this term in the denominator, x cubed plus 1. Then we need the differential of u, so we just differentiate it and use the power rule to get 3x squared, and then the constant becomes 0. And of course we need dx at the end. And so we get that dx is equal to du over 3x squared. And now you probably already see what will happen if we have a new integral where we use our method of substitution. We have x squared, the same, the numerator, and here is u squared. And now dx will be du over 3x squared, which is very nice because now this x squared in this numerator and this new denominator will cancel out, giving us an integral of, it seems like 1 over 3u squared in du. So let's continue. This integral is equal to the same integral from 0 to infinity of 1/3 times u to the negative second power. Do you see why? Because u to the negative second power is just 1 over u squared, which is, when we multiply it times 1/3, we get exactly what is in here. And we can just evaluate this using the reverse power rule. We're going to take the power plus 1, so u to the negative 1, multiply it by this coefficient here, and get negative 1/3, right? Because minus 2 plus 1 is minus 1. We multiply it by that, and then we multiply by u to the negative first power, also power raised. And then we can add a constant, but not really, because then we can substitute back in the function we had of x for u, and it is going to equal negative 1/3 times what is u to negative first. It's going to be 1 over u, and u is equal to x cubed plus 1. And this is going to equal simply negative 1 over, it seems like 3x cubed plus 3. All right, and we have our bounds from 0 to infinity. Let me erase the board real quick and then we'll proceed. So now that we found the antiderivative of this function, we can then use the standard method for evaluating improper integrals. So let us define a new variable, as it's commonly called t, which is going to be greater than our lower bound of 0. Then we can evaluate the integral from 0 to t of this large function. And then we use just the fundamental theorem of calculus. We subtract the higher bound from the lower bound of the antiderivative to get minus 1 over 3t cubed plus 3 minus, then again, minus 1 over 3 times 0 plus 3, which is just going to equal the same minus 1 over 3t cubed plus 3, and this evaluates to 1/3. So now that we have this integral for a general upper bound of t, we just take the limit as t approaches infinity of this integral. The limit as t approaches infinity of what we evaluated is right here, 3t cubed plus 3 plus 1/3. Well, this is just equal to, notice this first part right here. We can use the sum of the limits, of course, but this first part in the sum is going to approach 0. As t gets bigger and bigger, this fraction approaches 0. And so this limit is just equal to 1/3. And that is going to be the answer to our integral. And that is it for today's video. Thank you all for watching. Hope you learned something about using the method of substitution to evaluate such integrals. And I will see you in the next video.